Have you ever pondered the possibility of dimensions beyond our familiar three of length, width, height, and the added dimension of time? Let's embark on a mind-bending journey through the dimensions. We begin with the zero dimension, a point devoid of length, width, or height, a mathematical singularity, if you will. From this point, we extend into the first dimension, a straight line stretching infinitely in one direction, like a number line or a wire. Now imagine adding another line perpendicular to our first. Welcome to the two-dimensional plane, a flat surface with length and width, but no height. A sheet of paper or a computer screen are perfect examples of this plane. Adding another perpendicular line, we enter the realm of the familiar, the third dimension with length, width, and height. This is our tangible world, filled with physical objects. Now add the dimension of time, our fourth dimension, where events occur sequentially. Now imagine if there were more dimensions than these four. How would they look like? What would they mean? Welcome to the world beyond the fourth dimension, a realm where the laws of physics as we know them start to take on new forms. As we journey further, the dimensions become increasingly complex and abstract, yet they hold the key to understanding our universe in its entirety. Let's consider the fifth dimension. If time, the fourth dimension, is a straight line along which we move, then the fifth dimension is like a branching tree, where each branch represents a different outcome of an event in the fourth dimension. Imagine standing at a crossroad. Each path you could take exists simultaneously in the fifth dimension. Moving on to the sixth dimension, it's a plane of all possible worlds, with the same starting conditions as ours. Think of it as a library where each book is a different version of our universe, but all beginning with the same Big Bang. The seventh dimension adds another layer of complexity. Here we have sets of possible worlds with different starting conditions. If the sixth dimension is a library, the seventh is an entire city of libraries, each holding books of universes that began differently. In the eighth dimension, we find every possible universe with the same laws of physics and starting conditions. It's like a country of library cities, each city holding books of universes that obey the same laws of physics as ours. The ninth dimension introduces planes with different laws of physics and constants. So now our country of library cities becomes a planet, with each country housing libraries of universes that operate under different physical laws. Finally, the 10th dimension encompasses all possible universes that could theoretically exist based on different initial conditions and physical laws. It's like an entire universe of planets, each planet having countries of library cities, with each city holding libraries of universes that began differently and operate under different laws. Each additional dimension opens up a whole new realm of possibilities, each more mind-boggling than the last. As we delve deeper into these dimensions, we begin to glimpse the sheer complexity and beauty of our universe. Now brace yourself as we venture into the 11th dimension, the pinnacle of multidimensional theories. This is where the concept of dimensions really starts to bend our minds. The 11th dimension is not just another extension of the physical world, but it is a realm that encompasses all possible universes that could theoretically exist based on different initial conditions and physical laws. In this vast array of possibilities, each universe has its own set of physical laws, initial conditions, and even dimensions. It is like a gigantic library of universes, each one unique and bound by its own rules. This is the concept that string theory, a framework in physics that attempts to reconcile quantum mechanics and general relativity, embraces. But why is the 11th dimension so important in string theory? Well, it comes down to consistency. String theory, which proposes that the fundamental constituents of reality are one-dimensional strings rather than point-like particles, requires the existence of 10 spatial dimensions and one time dimension to remain mathematically consistent. In other words, without the 11th dimension, string theory would fall apart. It would be like trying to play a symphony with a single violin. The beauty and complexity of the music come from the interaction of many different instruments, and in the same way, the richness of our universe comes from the interaction of multiple dimensions. The 11th dimension is also significant because it could potentially unlock the secrets of the universe. It could explain the nature of dark matter, the mystery of gravity, and even the origins of the universe itself. It is like the key to a door that opens up a whole new world of understanding. So, as we delve into the world of string theory and the 11th dimension, we find ourselves in a realm where reality becomes almost fantastical. It is a place where our conventional understanding of the world is turned upside down and where the impossible becomes possible. So, in the grand scheme of things, we exist in a universe of unimaginable complexity, with dimensions extending far beyond our perception. A thought to ponder, isn't it?